All right, buckle up, because today we're diving deep into the world of AI problem solving.
Specifically, how to make AI better at math.
Right. And we've got this stack of papers from OpenAI that you sent over,
Yeah.
all kind of exploring these fascinating approaches to this.
What I find really interesting about this area of research is that it's not just about feeding the AI more data.
Right.
It's about looking into the how of learning, something that we kind of just intrinsically do,
Right.
but we don't really think about too much.
Yeah. No, it's funny. I was thinking about that when I was reading through this first paper. Let's verify step by step.
Okay.
And they introduced this concept of process supervision,
Right.
which I really, it really resonated with me.
Yeah, and so, I mean, the researchers in this paper, they draw this really important distinction between what they call outcome supervision,
Okay.
which is like, you're checking the answer at the back of the book, right?
Right.
You're just looking to see, did you get it right or wrong?
Yeah.
Versus this idea of process supervision, where it's not just about the answer itself, but understanding the steps, the logic,
Right.
the kind of the path that you took to get there.
It's like, I don't know, it's like the difference between seeing a magic trick
Yes.
and understanding how the illusion works.
A perfect analogy. And that's what the OpenAI team is really emphasizing here. This idea that process supervision, this understanding of how the AI arrived at an answer, it's not just some like academic curiosity. It's actually crucial if we want to build AI systems that are truly reliable, especially for these really complex tasks.
Well, yeah, I mean, especially if you were, for example, if you were trusting an AI to make medical diagnoses, right?
Absolutely.
Like, you wouldn't just want the AI to be like, take 2 of these and call me in the morning.
Exactly.
You'd want to know, well, how did you arrive at that?
What were the factors you considered? What symptoms did you weigh? What's the reasoning behind this treatment plan?
Yeah, like, show your work.
Exactly.
Yeah.
Just like our math teachers used to say.
Exactly.
So how did they actually put this idea of process supervision to the test?
Yeah, how do they actually do it?
So they took this model called GPT-4,
Okay.
which you've probably heard of.
Yeah,
It's been in the news a lot lately.
very much so.
And they presented it with a series of math problems
Okay.
ranging in difficulty from pretty basic to mind-bendingly hard.
Okay, so like across the spectrum.
Across the spectrum, yeah, they wanted to really throw everything at it. But here's where it gets really interesting. They didn't just flood GPT-4 with tons and tons of data.
Okay.
They didn't just give it the answer key and say, go learn.
Interesting.
They used this technique called active learning,
Active learning. Okay.
where instead of just focusing on getting everything right,
Right.
imagine if you were studying for a test, and instead of just reviewing everything, you specifically focused on the problems that you almost solved correctly.
Okay.
Like, you were on the right track, but you made a little mistake somewhere.
Right.
Those almost there moments, that's where the real learning happens.
Because you're like, oh, I see where I went wrong.
Exactly. You're like,
Wow.
I see my misstep.
Yeah.
And that's precisely what the researchers did with GPT-4.
Interesting.
They focused on the answers that were close, but not quite right,
Right.
to see where GPT-4's logic was breaking down. And by using this active learning approach, combined with process supervision,
Right.
they actually got some really, really impressive results, hitting a 78% success rate on this really challenging math test.
Wow. Okay. So not only did they get, it sounds like they got really good results.
Yeah.
But they did it in a way that's more transparent.
Yes,
Like, we can actually understand what's happening.
exactly. And that's huge,
Yeah, which is huge.
especially if we're ever going to trust these systems.
Exactly. Exactly.
And that's just the first paper.
Oh, there's more.
Building on this foundation of process supervision, the next one you sent, V-Star, introduces an even more, I think, more intriguing approach.
Ooh, okay. I'm already hooked.
Yeah.
So V-Star, tell me about it.
Yeah.
I'm already hooked. So V-Star.
Tell me about it.
So V-Star, it takes this concept of process supervision
Oh, right.
and it throws in like a really fascinating twist.
Right.
Instead of having one AI trying to solve these problems,
Right.
imagine you have 2
Okay.
working in tandem.
Like an AI buddy system. Exactly. Like an AI buddy system for problem solving.
I like it.
So you have one, what they call a generator AI,
Okay.
whose job is to actually tackle the problems,
Right, right.
come up with the solutions.
Okay.
And then you have this other AI called the verifier. And the verifier's job is to scrutinize,
Oh.
to like really look closely at the solutions that the generator's coming up with.
So it's like having a built-in critic
Yes.
to like help you refine your work.
Exactly. It's like having a built-in critic or like a really, really meticulous editor
Right.
who's checking everything.
So it's not just about finding the right answer, but it's also about having a system that can look at itself and be like, well, that wasn't quite right, but I think I see where I could improve.
You got it. You
Yeah.
got it. It's this constant learning and improvement. And they tested this V-star system on both math problems and code generation,
Okay.
which are very, very different types of problems, right?
Right. Yeah.
But what's really remarkable is that this dual AI system,
Right.
it learns from both its successes and its failures. So when that verifier AI says, nope, that's not quite right,
Good.
the generator takes that feedback
Right.
and it refines its approach.
That's really interesting. It's like they're playing a game of, I don't know, intellectual ping pong or something,
I love that.
where they're bouncing these ideas back and forth until they land on,
Yes.
the most elegant solution.
Exactly. Exactly. And the researchers found that this whole back and forth process, it led to some really, really impressive results. They actually found that V-star outperformed other state-of-the-art methods,
Okay.
including Google's own what they call a self-consistency approach.
Wow. Okay. So beating out Google in the AI arena, that's no small feat.
Exactly. Exactly. So it really speaks to the power of this V-star system.
Okay, so we've got process supervision, we've got these dueling AIs.
Right.
What's the next layer of the cake here?
Okay, so the third paper, Quiet Star, it dives into something even more, I think, mind-bending.
Okay.
They're exploring this idea of training an AI to essentially think internally.
Ooh, okay. Like almost like a subconscious process.
Yeah, almost like a subconscious process.
Almost like a subconscious process.
Yeah, so with Quiet Star, the AI isn't just like, spitting out an answer right away. It's actually being trained to sort of explore different pathways in its own little AI brain
Okay.
before it gives that final output.
So it's like they're really trying to like replicate that aha moment we get.
Yeah.
Where you've been wrestling with a problem and then suddenly the solution just pops into your head.
Exactly, and that can be a really hard thing to replicate in an AI system.
Right, because like you were saying with those earlier papers, it's not just about speed and efficiency.
Exactly, it's about emulating that more nuanced, human-like thought process.
And I imagine that's incredibly complex from a technical standpoint.
Oh, absolutely. But when you think about how we solve problems as humans,
Yeah.
it's very rarely this linear, straightforward path.
Yeah, it's messy.
Yeah, we go on tangents, we hit dead ends, and sometimes we have to circle back to an earlier idea with a fresh perspective.
Exactly. And it sounds like that's what they're trying to capture with Quiet Star.
Precisely. And what's fascinating is they're finding that this more human-like approach to AI learning,
Okay.
it's actually leading to some significant improvements, especially in tasks that require common sense reasoning, which has always been a big challenge for AI.
That makes sense because common sense is all about understanding the nuances of a situation.
Right.
And it's not always clear cut.
Exactly. So Quiet Star, it's like they're encouraging the AI to slow down, to think more deeply, to really consider different angles before arriving at a solution.
I'm seeing a pattern here with all these papers. It's like this emphasis on the quality of thinking rather than just, how fast an AI can crunch numbers.
You've hit the nail on the head. It's about moving beyond just brute force computation and toward a more elegant and thoughtful approach to problem solving.
It's like instead of just being good at math, it's about becoming a mathematician.
I love that analogy. And that brings us to the final paper you sent, Learn Beyond the Answer, which takes this idea of AI reflection to a whole new level.
Learn beyond the answer. Okay, so they're not just happy with the AI getting the right answer. They wanted to understand why and how it got there.
Precisely. This paper introduces something called reflective augmentation.
Reflective augmentation. Okay,
Yeah.
break that down for me.
Imagine a student getting their exam back with notes from the teacher.
Okay, been there?
Right, we've all been there. They're graded not just on the final answer, but on showing their work and explaining your thought process.
Right.
That's what reflective augmentation is doing for AI. It's prompting the AI to analyze its own solutions after the fact, to go back and understand not just what it got right or wrong, but why.
So it's like they're encouraging the AI to become its own teacher in a way.
Exactly. To critically evaluate its own thinking process and learn from its mistakes, just like we do.
Because sometimes realizing where you went wrong is just as valuable as getting the right answer in the first place.
Absolutely. It's how we grow and refine our understanding. And the researchers are finding that this reflective process is leading to some really promising results. The AI is able to tackle more complex problems, ones that require deeper levels of understanding.
It's like they're pushing the AI to move beyond just pattern recognition to actually engage in higher level reasoning and problem solving.
Exactly. And I think that's incredibly exciting. What fascinates me about all four of these papers is that they're not just trying to build faster or more powerful
It's
AIs.
almost like a paradigm shift.
It is. It's about cultivating this more human-like reflective way of learning. And that opens up so many possibilities.
It really does. So it seems like the key takeaway here is that when it comes to AI, and maybe even to our own learning, it's not just about finding the right answer.
It's about understanding the why, the thought process, the journey of getting there.
And maybe by teaching AI to think more like us, we might learn a thing or two about how we think as well.
Now, wouldn't that be something? That's a thought I'll be pondering for quite a while.
It's been a fascinating deep dive. Thanks for sharing your insights with me.
My pleasure. Until next time.